For the first one here, the ratio, of course, is going to be the ratio of diameters. How do we figure out which one goes on top? Pretend that looks like a motor. So if we cut the belt, that's the one that's going to stop. So that is the driven pulley. That goes on top. So it's a 10-6, which reduces to 5-3. This one I gave you debt to income. So which number goes first or on top, however you want to set it up. The debt is the 1,200. So the income is the 4,000. What can each of those be reduced by? 300. So the zeros divide out. We've got what? 4. Oh, 3 ain't gonna. 300 ain't gonna work. We'll do 100 first, and then we'll go from there. So you got 12 over 40. Both of those can be divided by 4. So you got 3 to 10 debt to income ratio. So 3 out of every $10 you earn is going to pay off debts, which is actually not a bad ratio. That's a fairly low ratio. Unit rates. What's unique? What's the word unit rate? What does that mean? It's not a ratio. Rate means it's going to be two different labels. So it's $720 in 40 hours. How do I turn that into a unit rate? I divide by the denominator, which is the 40 hours, or not hours, just by the number, the 40. So this is 1 hour. Divide by 40 up here is going to be $18. So that's $18 over 1 hour. And when it's a unit rate, remember, we can kind of hide it or abbreviate it so the fraction is just in the units. So $18 per hour. What's that? Yeah, it's not that hard to do. You got to stay at a job for a while to work your way up there. Well, yeah. Yeah, that's different. But no, I mean, coming out of school, yeah, you're going to be looking at 12, 13, maybe 14 an hour. But if you stay a place for a few years, it's not that hard around here to get up to 18. The problem is you're competing with tips, and not getting tips really sucks at first. Yeah. So 300 miles in 5 hours. What are we going to do to reduce that to a unit rate? What are we going to divide each of those by? The 5. Very good. So that's 1 hour on bottom. 300 divided by 5 is 60 miles. So 60 miles over 1 hour, or 60 miles per hour. Connection's bad. What's that? Yeah, that's just my connector back here is getting bad. This computer is a couple of years past its replacement time. So when it goes blue or yellow, that's just the connection wiggling. Okay. So then we need to talk about what happens when we have a ratio. Let's say that we know you need to have a 1-to-3 debt to income ratio to be eligible for a loan. And right now your income is, let's say it is $3,300 per month. So what is the most you can have in monthly debt and be at that ratio? Well, which of these numbers, the 1 or the 3, represents income? Hopefully it's the 3, right? Hopefully the smaller one is your debt. So that's $1,300. Now in these ratios, remember, we have to have the units have to be the same within a ratio. Since there are no units here at all, that's telling us this is a ratio, not a rate. And since that's a ratio, that means whatever units are here have to have the same units on the top or bottom with it. So on top, it's going to have to also be dollars. And how do we find that number? Cross multiply and divide. Does that process look familiar? When you have a proportion like this, you have two ratios or two fractions. There are always going to be two numbers that are diagonal to each other. In this case, the 1 and the 3,300. You multiply those two numbers that are diagonal. 1 times 3,300 is 3,300. Then you have another number, a third number, that's on the diagonal with the missing number, which is the 3. And so you divide by that 3. So 3,300 divided by 3 is 1,100. So that missing number is 1,100. So that's telling us the most debt you could have is $1,100. Now, the reason that's important is, we mentioned this a little bit yesterday, is let's say you have, with your car loan and credit cards and student loans or whatever, you already have $800 in debt for the month. Well, if you want to go buy a house, you've only got $300 worth of wiggle room there. You have to keep your house payment under $300. So you're not looking at a... you know, I used to do a lot of home inspections for people buying houses. And I still do occasionally for friends. In the last few years, I've actually helped a couple of friends get into houses where the house payment itself was under $300. One of my good friends about 2 years ago got him into a house. The payment and then the escrow for taxes and insurance, it's like $485 total a month. No, that's not bad. Yeah, that doesn't include the taxes and insurance. That's just the payment for the loan itself that's in that $300. Let's see. Let's say that we know our car gets 24 mpg. We want to know how many gallons it would take to go 504 miles. So 24 mpg is not a ratio, it is a rate. Right now is expressed as a unit rate. If you remember, we said yesterday, 24 mpg, we've got to look at that and realize that is 24 miles over 1 gallon. That is the form we needed in to work with it. Now that is a rate because the units are in it. There are units in it. A ratio would have no units there. Because there are units here, we have to match up our units. Whatever units are here, we have to have the same units over here. Miles and miles. Whatever units are here, we have to have the same units over here. So gallons. So just by looking at that, it tells us where the numbers in the rest of the problem have to go. Where does the 504 have to go? On the top, because it's miles. And now to find that missing number, cross multiply. 1 times 504 is 504. And then we divide by the 24, which is what, 21? So 21 gallons. This cross multiply and divide that we're doing here, I want to take a closer look at that. This is, let's say this is x over 7 equals 12 over 28. And I want to find out what x is. Now I put x where it is on purpose here because with x on top here, I could actually solve this like an equation. If I asked myself what was done to x, well, I could view this as x has been divided by 7. And if I did that, how would I solve this? Well, I'd multiply by 7 to get rid of that dividing by 7. So I'd multiply this side by 7 as well. So here I'm left with x. And if I look at what's going on over here, I have 12 over 28 times, I have to make that 7 over 1. I am going to multiply the 12 times 7, which is 84. And then I'm going to divide by the 28, which gives me 3. So x is 3. So that process of cross multiplying and dividing is just shortening this up, the process of solving that equation. So all I did was multiply the 7 times 12 and divide it by 28. There's another way I could look at that. What's that?
Sorry, I was going to say, like the way you wrote it to me before that.
that you're usually doing?
Yeah.
They're strictly cross products, like that?
Yep.
Yep. The same principle that I just showed here up above for solving an equation could be applied. What I could do is multiply by 7 to get rid of the 7 over here, multiply by 28 to get rid of the 28 on that side. We looked at that multiplying by common denominators to get rid of fractions within an equation, or we will look at that coming up in the next couple of weeks. And what that results in is basically this cross multiplication here. You multiply the numbers that are on the diagonals. So the 7 and 12 are diagonal with each other. 7 times 12 is 84. Then you multiply the other diagonal. X and 28 are diagonal with each other. X times 28 is 28x. And in a proportion, if two fractions or two ratios are equal to each other, their cross products have to be equal. So the 28x has to equal 84. So now to solve that equation, what do we do to get x by itself? Divide by 28. So that's gone. X equals 3. Oops, make that look like a 8. X equals 3. Well, you can see to solve this equation, this number that's diagonal with the x is always going to be multiplying the x. And to solve it, we're always going to divide by it. So that's where that cross multiply and divide came from, is we're saving that extra step at the end where you're just dividing to solve the equation. There will be times where we have to apply the full cross multiplying because we will run into things like x plus 3 over 11 equals 12 over 33. To solve that, I can cross multiply this way, 11 times 12, which is going to give me 132. Then I cross multiply in this direction, x times 33. I'm going to write that as 33 times x plus 3, like that. And now I know that this product has to equal that product. So 33 times x plus 3 has to equal 132. Now, I put this one first because it's easier for me to have the variable on the left side of the equation because that's what I'm used to. But it doesn't matter which one of these cross products you put first. They have to be equal to each other either way. So now to solve this, I'm going to distribute the 33. 33 times x is 33x. 33 times 3 is 99. Then what do I have to do to solve it from there? Subtract 99. 33x equals 33. And then what? Divide by 33. X equals 1. And of course, if we wanted to, we could put that back in here. If x equals 1, x plus 3 is 1 plus 3, or 4. So you could double check. Does 4 times 33 is 132, and 11 times 12 is 132. So the cross products are equal. We might run into something like this. So again, it's not just x that we're solving for, it's 5x. So again, we're going to cross multiply. 9 times 25, which is just going to give us 225. And 5x times 15, which is just 75x. And again, those two products have to be equal. 75x equals 225. What do we have to do to solve that? Divide by 75. So that's gone. X equals 225 divided by 75 is 3. So x is 3. How about something like this? We can still do the cross products. We've got the 4 and 9 are diagonal, so we've got 4 times 9, which is 36. We've got x and x that are diagonal. What's x times x? X squared. So this is just telling us x squared has to equal 36. How do we solve that? What's the opposite of squared? Square root. So x equals, what's the square root of 36? 6 or negative 6. If we had 6 over 4 equals 9 over 6. 6 over 4 divides out to be 1.5. 9 over 6 is 1.5. But if we had negative 6 over 4 and 9 over negative 6, negative 6 over 4 is a negative 1.5. 9 over negative 6 is a negative 1.5. So either one of them makes that true. When you have x squared in an equation, a lot of times there are two different answers. So you gotta be careful with those.
So it doesn't matter if we do negative minus 6 or...
Most of the time we're going to be looking for the positive result. Yeah. In my math lab, it'll tell you if it wants the positive result or if it wants both results. Most of the time in practical application, the negative number doesn't have any meaning. Okay. So let's say that the state requires a minimum teacher to student ratio of 1 to 18. How many teachers are required for (576 students? So we have to be given a rate or a ratio. What are we given in this problem? We are given 1 to 18, which is a ratio because there's no units in it. What does the 1 represent? That's teacher. The 18 is students. So now when we write the other ratio within this proportion, the other half of our proportion, we have to make sure what matches up. Whatever number represents teachers has to go on top. Whatever number represents students has to go on bottom. The 576 represents which one? Students. So that must go on bottom. So then 1 times 576. Now here, we don't have to cross multiply and write an equation. Since this number is that what goes in that spot is what we're looking for, we can just cross multiply and divide. 1 times 576 is 576. And we can divide by the 18, which is 32. So it would require 32 teachers for that many students. Another application of these ratios is similar shapes. By similar shapes, I mean we take a shape and we enlarge it or reduce it. So I'm going to enlarge this one. So let's say the sides on this original shape, and I'm going to mark it that these two angles are the same and these two angles are the same, just so we know the shape hasn't been rotated at all. If I say that this here is 8 inches, 12 inches and 14 inches. And then over here, this has become 12 inches. And I want to find those other two missing sides to figure out what they have to be. The ratio between corresponding sides has to be the same throughout the two figures. Now, by corresponding sides, I mean the same side before the enlargement and after the enlargement. So on this figure, after the enlargement, the only side that I know the length of is the 12. What side from the other figure corresponds to the 12? The 8. I made this one easy for you by leaving them in that same orientation. They're on the same side. So the 8 corresponds to the 12. So I have to set up a ratio of those sides. It does not matter whether I do 8 over 12 or if I do 12 over 8. Makes no difference. The inches disappeared because they cancel out. They're both in inches. Let's say we are looking for x. And I'm going to use this one over here first. Where does the x have to go, top or bottom? Well, we need to figure out what does it relate to. Does the x have a relationship to the 8? Well, it's not corresponding sides. They're not the same side before and after. The x does have a relationship with the 12, though, because they're from the same triangle. So x has to go on bottom because it has that relationship with the 12. Now, what goes up here in this spot has to have a relationship with the x, and it has to have a relationship with the 8. Yeah, the x is from the same figure as the 12, so these two must be from the same figure. So it's one of these two that has to go up there. And the corresponding side would be the 12. So that does have to be 12 there. And now to find x, we are going to cross multiply and divide. 12 times 12 is 144. And we divide by the 8, which gives us 18 for x. So x is 18 inches. To find y. Now I could go back, I could still use 8 over 12, or like I said, I could use 12 over 8. It doesn't matter which way I do it, as long as I make sure I maintain those relationships. Since I used 8 over 12 before, I'm going to keep using 8 over 12. So I'm going to ignore this for right now. So I have that 8 is related to 12. This is the before and after. On the other side over here, now I need to find y. Where is the y going to go? On bottom, because it is from the same figure as the 12. On top, then it has to be related to the y and to the 8. Well, both the 12 and the 14 are from the same figure as the 8, so it has to be one of them. The 14 is the corresponding side with the y, so 14 goes up there. And we cross multiply and divide. 12 times 14 is 168. Divided by 8 is 21. So y is 21 inches. Not so bad. We won't always keep it nice and neat like that. Might do something like this. So here we've reduced the size of this, and we've twisted it around and maybe even flipped it over. But what I do know here is that this angle is the same as this angle. And I know that this angle is the same as this angle because they're marked. That one arc indicates that those two angles are the same, and the two arcs indicates those two angles are the same. Which of course means that this angle and this angle must be the same. Because whatever's left, the last one has to be the same with the first two are. So now if I give you sides, let's say that this side here is 12 inches. This one here is going to be 20 inches. And this one here will be 22 inches. And over here, I give you that this side is 5 inches. I've got x and y. So all I have on this smaller triangle is the 5 inches. Which side from the other triangle relates to it, is corresponding to it? The 20 is. And the way we know that is we look at the angles. The 5-inch side is between these two angles. I've got them marked with red and green. So we have to go to the other triangle and the same two angles. I've got them marked with red and green there as well. So this side is between the same two angles as the 5 inches. So the 20 inches and the 5 inches correspond to each other. Now again, it does not matter which one I put on top and which one I put on bottom. I'm used to putting the smaller one on top, so I'm going to do that. So I'll put 5 over 20. Again, the inches cancel out, so I don't need the inches on there. Now I might get asked, could I reduce that to a 1 over 4 if I wanted to? And sure you could. That would be just fine, but we don't have to. And the other side over here, let's say I want to find x first. Where's x going to go? It's from the same figure as the 5, so it goes on top. What goes down below the x? Yeah, 12. That's the x is between the green and blue angles, so over here between the green and blue angles is the 12. So 12 relates to the x because they're corresponding sides. 12 relates to the 20 because they're from the same figure. And we solve it by 5 times 12 is 60. Divided by 20 is 3. So x here equals 3 inches. Now I'm going to keep using that 5 to 20. If I did 20 over 5, all it would do is flip everything else over. The other ratio would be upside down as well. I need to find y, so where's the y going to go? Well, that is from the same figure as the x. Or from the 5, I should say, so that goes on top. 5. What goes below the x? Or below the y? It corresponds to 22. I can't talk today. So we're going to cross multiply. 5 times 22 is 110. Divided by 20 is 3.5. Does that look right? Something, no, not 3.5. 5.5. Now, some days the little hamster refused to get on the wheel. This morning he's just kind of laying beside it, swatting it with his paw. Coffee or something. What's that? Yeah. Okay. So there are all sorts of applications for this. We've seen the student teacher, we saw the mileage, the pay ratios. We could also look at, let's say that you're looking at your investments, and an investment of $4,000 returns $120 over a given period. And I want to know how much is required to invest in order to return $300. Now again, we can set up this ratio however we want. We can do 4,000 over 120 or 120 over 4,000. It really doesn't matter. Let's do the $4,000 over the 120. Do I need to put the dollar signs on them? No, because they're the same. All I know then is whatever's on the other side, the units on top and bottom better be the same. But we're looking at dollars again, so we're probably pretty safe there. Where does the 300 have to go? It's going to have to go on bottom. The reason is that 120 represents the return or the interest, and the 4,000 is the investment. So over here, the top number has to be the investment, which is what we're looking for, required investment, The bottom number has to be the return, which is the 300. So we cross multiply and divide. 4,000 times 300 divided by 120 is $10,000. Any questions? You look confused.
No, I completely just it's fine.
Okay. Okay. So you have 24 items or 24 units of a certain product. Cost $84. How much would 35 items cost? Assuming that there is no discount for buying more, how much would the 35 items cost? This is not a ratio. The units are not going to disappear. This is a rate, but it is 24 items for $84. Or we could have $84 per 24 items. It really does not matter. On the other side, though, what number do we know? We know 35 items. That has to go on top, because items are on top in the other rate. And if we cross multiply and divide, 84 times 35 divided by 24 gives us what? What's that? 122.50. Perfect. Any questions? In your notes, quick, find X in that proportion for me. Figure out what X has to be. So if we cross multiply, 9 times 48 here is what, 432? 8x times 27, well, 8 times 27 is 216, so it's 216x. 216x equals 432. What do we do from there? Divide by 216. X equals 2. How do you guys feel about these? Not too bad? Better than a sharp stick in the eye? Okay. I shouldn't say new quiz, but there is that quiz that we assigned yesterday that is due tonight at 11:59 p.m. And there is that homework that is due for Monday. Again, those aren't really new because we assigned them yesterday, but remember they're out there. I'll let you guys have that last 8 minutes if you want to. The computer lab next door will be open if you want to work on your quiz. I recommend that you do the quiz before you do the homework, because this quiz, again, is related to the homework that was due yesterday. Otherwise, have a good weekend, and we'll see you on Monday.